I will tell you just a little bit about Science Gateway's Community Institute, which brings you this webinar. We are here to bring together a community of people who build and use gateways in order to share experiences, technology expertise, and best practices, and generally at little to no cost to the community. This is funded by the NSF so that you don't have to pay for it, and our services are available both online and in person. So I'm going to tell you a little bit about those services very briefly and to give you an idea of what we offer. Our incubator is here to be like an incubator for startups, and essentially it offers both a boot camp that will help people learn about various best practices with getting gateways created and sustaining them. And those same folks who teach at the bootcamp also are available for one-on-one consulting on projects, whether it's usability or sustainability or cybersecurity or any of the other topics that are covered during the bootcamp, which is an intensive week. Our second area is Extended Developer Support, and our presenters today are both from that area. They have provided support using these two tools, and we have quite an array of talent in this part of our organization who can work on projects up to quarter time for up to a year. You just apply for that on our website, as you would also for incubator consulting. The Scientific Software Collaborative has produced a gateways catalog, which has both software and gateways that are listed and searchable, and I encourage you, if you have a gateway, to post it there, and if you are looking for resources or software that might be useful, to go there and have a look around. Community engagement and exchange is what brings you this webinar, as well as our annual conference, which will be in late September this year in Austin, Texas. You can join our newsletter that we send monthly to find out about that, and registration will be opening at the end of June. So we hope you'll join us for that. And last but not least, workforce development is our area that is providing various kinds of internship and educational experiences for students, as well as bringing people who can teach with gateways into the world of gateways. And we are offering this summer at PERC a hackathon, which will involve students working on several different gateways to work on components of those. So that's another way to get your students engaged. One quick pitch for getting your feedback at the end of this webinar. It helps us get ideas about new webinars, as well as find out whether we're serving your needs. So it takes actually less than 30 seconds, and we'll provide the link in the chat area when that happens. It's available now. You could evaluate if you want now, but we will put that chat link up in chat for you later. So with that, I'm going to stop sharing my screen and let our first presenter today, who is Marcus Christie from Indiana University, get set up with his slides. He is going to be talking about Keycloak, which is an identity and access management application that he has used for one of our projects supported by Extended Developer Support. If you want to know more about this after the webinar, you feel like your interest has been piqued, he has written a tech blog on our website about this topic as well, and you can go check that out. But also, we are available for consulting, as I mentioned. So with that, I'm going to hand it off to you, Marcus, when you're ready. Oh, I don't see Marcus. Did he get dropped by accident? Oh, he did. Okay. Hey, Steve, how would you like to start now?
Hey, that'd be fine.
Okay, we'll do that. Okay, so go ahead and share your screen, and we'll get going with that.
All right.
And while you get your screen up, I'll introduce you. Steve is from Purdue University. He also works as part of our Extended Developer Support team, and he is going to talk about GraphQL, which I'm not even going to do justice to by trying to explain it, so he'll talk about it now.
Okay, yeah, thanks for the intro. So I'm going to talk about GraphQL, as you said, which is a query language and a runtime for API design that comes out of Facebook, and they use it for their website in addition to all their myriad apps. So it's got quite a presence out there. You can see there's a trademark disclaimer, and but that's about the end of it. The code is all released under MIT license, so it's open source, and there isn't a problem with using it in your gateway if it's something that's appealing. And this isn't really a pitch to give a bit of a spoiler for my own material here. We didn't end up using this for the gateway that we were looking at it for beyond the mock-up stage, but I thought that there was enough interesting stuff embedded in GraphQL that it might be better suited for another project in a similar area. So what I'll do is I'll kind of walk through a simple API design using both the REST API and GraphQL and talk about some of the trade-offs between them. And if there's anything that jumps out at you that you have a question about, please go ahead and type it in the chat there, and I'll get to that. To begin with, as I said, there's two parts of GraphQL, the query language itself and the runtime. And I'll start out by talking a bit about the query language. It's most similar to other graph-oriented systems like Gremlin or Sparkle, but since most people are more familiar with SQL, I'll use that as a comparison point. GraphQL doesn't require or even particularly synergize with actual graph stores like Neo4j, but you can think of any relational data as composing a graph. For demonstration here, we have the simplified schema where we have users, work groups, and projects. Users belong to work groups, and work groups are assigned to projects. And then we have some relational tables that specify how they connect to each other. And the graph embedded here shows how we can think about those foreign keys in the graph form. Every row just becomes a vertex, and every foreign key becomes an edge. In the project that we were looking at this for, we were actually using a document store that had big JSON documents in it. And that turns out to work pretty well too, because if you have structured data like JSON or XML, you can think of that as a tree, and a tree is a type of graph. So it's really a matter of perspective more than implementation, the graph part of GraphQL. Anyway, we're going to build a little bit on this schema going forward here. I'm imagining here that you might have a page for this data that as a summary of the effort behind a given project. And to do that with SQL, you'd have a query like this. What you want to get out of it essentially is the people that are working on the project, where they're coming from, and in what context, what work group context they're associated with respect to that project. So to do that, you could use the SQL query like this, and the particulars of the query don't matter all that much. But the thing that I point out is that we have to specify a strategy to reduce the dimensionality of the data so that it fits into rows and columns. If you look through the query a little bit, the join types, the grouping, and the serialization of that array column into the groups, all that stuff is essentially trying to reduce the dimensionality. So, and that's maybe 70 or 80% of the query. And this is the main area where GraphQL really branches off and takes a different approach. The same query here in GraphQL, you see it doesn't attempt to collapse the dimensionality of the data. Instead, you write a deep query with nesting that reflects how the data actually relates to each other. And you get back a deep JSON document that mirrors the structure you put in. So you can kind of go back and forth here and line up project, groups, and see the names and the users. So this isn't strictly a win over SQL, it's just a different approach. It depends on your work case. If you were looking to assemble a spreadsheet, for example, the SQL response, I go back here, that's already effectively a spreadsheet, so that's perfect. But in a web context or for apps, which are sort of the same, if you think about something like React templates or another HTML templating strategy, this is the kind of data that you could feed directly into those and come up with a nice overview of the data more or less automatically by defining what your HTML looks like. So it's better suited for certain purposes. In order to make this work, what you do on the server is you define a type system that specifies what your data is. And you can see the simple example on the left here. It's just like the tables we saw earlier, except the foreign keys are represented directly as fields rather than living in a different type of their own. And we have this query type here there's a special structure, and it represents the entry point for queries. This can happen any way you choose, but I went with the basic strategy of providing lists of all the entities of each core type and a selector by name for a specific one. In return for creating this type system with annotations, excuse me, the runtime will generate some nice documentation for you, which is a screenshot you see embedded here. And it's just running a cut down hello world example and not this actual type system. But everything that you add into your types, including any markdown formatted comments you want to add, will come through in this documentation explorer. And even without the comments, if you just add descriptive type names, it's enough to get an idea through the automatically generated documentation of what's possible through the API. So that's a big win for something that you don't have to do manually. To actually resolve the data for these queries, you also need to supply a root object to GraphQL that mirrors this query type. So it has the same field names representing those methods, a project that takes a string, and projects, plural, that takes no parameters. And these are functions that are in charge of actually figuring out what the data is. They fulfill the type contract by returning what it says they do. So the projects function, for example, consults the database or whatever it has to do to find the project's names and alignments and returns them. It also has to return something for groups, but you can see here there's a circular dependency where projects have groups, but groups also have projects. So you can't automatically instantiate all of them, or you end up in an infinite loop. So instead what you do is you return another function that knows how to get the pertinent groups for a project if and only if they're actually referenced in the query. So you have this root object that matches the query type, and GraphQL walks the root object along with the query and invokes these resolving functions it finds as needed, storing their results in the response document. And that was a really quick overview, but if you're technically minded and want to know more about this, there's a complete worked example on the blog post that you can download, along with the Git repo that you can clone that has a complete worked example that's very similar to this. To get more directly into the comparison with REST API, which is what most people would use for this sort of thing, to use the GraphQL query that we were just looking at, which is down on the bottom left now, you only need to send it along with the GET request to the URL where the runtime is bound. So you don't need a specific client library to work with GraphQL, just any language that can do networking and that can understand JSON responses. As for the server, the reference implementation is in Node.js, but there are libraries for a dozen other languages. You can find those in the documentation. Now, considering a REST equivalent for this data, the basic first draft normalized REST design is quite similar to what I put here for the type or for the query type. It's endpoints for lists of each entity type and then ID selectors that get the attributes for specific entities. And you might go ahead and preemptively join the project's groups or the group's users and get rid of every third one of these endpoints, in which case it would match the type query almost exactly. So starting out, they're fairly much on parity. But you can see from the skeletal implementation of the client on the left here that it's completely different in terms of how the client interacts. And the difference comes in that it has to make a lot of different queries to get all the data that it needs for this summary page about the project. It has to loop through all the projects, get its groups, get its users, and if it wants to show this data in some sort of sensible way, it probably also has to stitch all these requests back together into a uniform data structure like the one that GraphQL gives you out of the box. Now, there are ways to avoid this. For the developer of the REST API might figure out that SQL query from a while back, a few slides ago, and put in an endpoint that has that specific data on it. And that's fine. But another thing that happens a lot is the existing endpoint gets decorated with options and parameters, which I show in the second thing here. But this creates a problem with consistency because you can no longer describe how your API works in the simple terms you started with, lists of resources and their corresponding detail endpoints. As they close the ticket on this, asking for the summary data, they might also have the sinking realization that the groups endpoint doesn't support including users or projects. And the user's endpoint doesn't support projects, and they have a choice then between having an inconsistent API or filling in those other things to make them consistent and essentially doing work that nobody's asked for. Then to continue with the hypothetical story about a gateway application, say we have this project overview page working, but the designer adds a related projects box to the summary page, and it's populated by looking at what else the pertinent groups are working on. So GraphQL can survive this change in requirements with no input from the server team. It could be made nicer at some point by adding a special related projects fields that handles filtering out the original project, and it might maybe score them more effectively than just counting up group membership. But prior to that happening, it at least works, and you can put it in front of users to gauge whether it's worth further effort. Conversely, with REST, you're back to the same problem you had with adding the summary endpoint, where you have this choice between just telling the client to loop requests inefficiently, further extending the endpoint with more query parameters, or what I suggested here in the purple, adding a new specific facility that, again, makes your API less consistent and requires documentation. So in summary here, that all sounds, to me anyway, that sounded pretty good. I think the ability to adapt to changing client demands without bloating up or hacking the data layer, I think of that as GraphQL's agility advantage, but it turned out to be more of a double-edged sword than a straight advantage. As I just demonstrated, GraphQL can be a real workhorse for projects that are in flux because they're new or because they're being rebuilt, rethought. A complete type system expresses all the functionality that's allowed under the system. So anything the users and developers come up with either already works or is genuine new ground for discussion and not just a permutation of existing ideas. So those are both great outcomes, either not working on something at all or working on something that is new and exciting, hopefully exciting, at least new. Especially when you have a distinct front and back end, it can really accelerate things anytime you have to avoid having one group of people block the other. Like the front end developers waiting on that summary query to be added to the REST API so they can show their user groups and get feedback. If they can just do that, then obviously it's going to accelerate the process. My sense from looking into this is that Facebook's main draw for this isn't that the expressiveness of the query language lets them run a lot of different apps and a lot of different phones and smart toasters and what have you. And they can all be driven from the same API service, even when their individual requirements of it are very different. So you may just have one gateway web app, but you can also think about parts of it as being different applications in a way, like the administrative backend. Maybe you have a statistics reporting system. These all use the same sort of common types you define in GraphQL, but they do it in ways that may not overlap with the ways you access those types for your core presentation. So if you're able to be flexible there, it will save you work on those other things too. And you may want a mobile app one day, and if you have GraphQL, that's one less thing you have to worry about in pursuing that. In the specific case of the gateway we are working on, our other client consumer was actually independent researchers who would be using our API, be it REST or GraphQL, to come up with their own studies about our data. So that's another thing to consider, and we'll talk about them a bit more in the cons column. Consistency. You can basically do whatever you want with GraphQL, so it's not a guarantee, but it tends to be consistent because types are the same type regardless of how you arrive at them, if that makes sense. So for example, at the top level query, you can choose a group by its name or a list of groups, and that group will operate the same and will have the same operations available on it as a group you get by going to a user and then selecting their group membership. In REST APIs that kind of grow and accrete over time, it ends up a lot of times when they mature being that different entities are represented different ways depending on how you come about them. They have different levels of annotation and omission depending on whether they're just tangential to your core query or if they're what you're looking at directly. And that's something that cannot happen in GraphQL. So that's what I mean by consistency. And finally, the thing I started with, the whole purpose was to avoid those round-trip network calls that the REST API typically needs to construct a page. And that turns out to be one of the less important things, but it's not nothing. So less latency is good. And to be able to do so without a persistent tunnel like a WebSocket is a bonus. The cons list is a bit shorter, but important, I think. One thing is that it's non-standard. Developers know how to make REST APIs. They've probably been doing it for most or all of their career. As a Facebook project, riding on the coattails of React, there is no shortage of community help, and this is not something that's going to be particularly difficult for anyone to figure out, but it's something to consider. And there's a lot to admire about REST APIs aesthetically, at least when the APIs are new and pure and before evolving requirements corrupt them. There's a whiff of a second system effect to GraphQL, especially when you consider we have HTTP 2 coming out now, which goes a long way to address the inefficiency of many request client models. So maybe rather than a whole new system, the solution might be to just do REST a little bit better and avoid some of the issues I pointed out earlier with it. Now, the last two here are the biggies that actually caused us to stick with REST for this gateway project. At some point, having a wild frontier of unexplored query possibilities goes from an exciting development opportunity to a credible danger to your operations. And it turns out not to be trivial to shore that up. For your REST endpoints, you can pretty easily discover by looking at your data what your worst case performance is, like what the largest queries are. And you can mitigate that if you need to by, denormalizing, caching, all the usual strategies. On the other hand, if you define a fully recursive GraphQL type system like I've suggested here, your API consumers are the ones in charge of what constitutes a worst case scenario. The thing that I like to think of to demonstrate this is the Bacon number, which you've probably heard of. Like you can connect any notable actor in Hollywood back to Kevin Bacon by way of their co-stars and their co-stars, and so on, hopping from movie to movie. And I think it's supposed to take 5 or 6 steps or whatever maximum. And you might find out that your data has a similar property, and that even if you have a lightly nested query, that it ends up bringing in huge swaths of your data, and it becomes expensive either to push it all out or to even find it in the first place if the indexing doesn't support it. There are a lot of mitigations for this. Of course, you can paginate things and only give the first 50 results. You can assign maximum complexities to the queries at parse time. And you can even go through and cost out each one of your resolver functions, saying this one takes 10 units of effort, this one takes 1, this one takes 5, and so on, and tally up all these costs before you try to run the query and reject it out of hand if it's just too much. And these are all things you don't have to do yourself. The community has made all these plugins. But just the same, it's not as simple as with the REST API, where with a couple lines you can just configure Apache to rate limit people, and then you can be confident about the performance of your website. So in the end, our decision was that hardening GraphQL wasn't really the problem we wanted to work on, and we'd rather focus on consistent performance. And I think that was the right decision because this was a much older system with functionality that's stable and that people have been using and relying on for a long time. But on the other hand, if we were re-envisioning the system to do something new, I don't know if we would have made the same decision. So that's, I realize a little bit scattershot, but hopefully that gives you enough of an idea about GraphQL to tell whether it might be appropriate for your project or not. I'd say the takeaway is that if you need to move quickly and you want to, move fast and break things as the old development thing goes, then GraphQL is great. And if you want to solidify something that already works, maybe not so much. Do we have any questions pop up in the chat?
So far, not yet, but that was terrific. I even understood a good chunk of it, and I'm not technical, so thank you.
Oh, great.
Thank you for that presentation. Yeah, but I have a question, which I'll ask while other folks consider whether they have questions too. I'm curious. So you were describing like why you decided to not use the GraphQL because of the hardening aspect, essentially, which I take to mean that you would have had to do stuff to make it substantially more reliable and not so on the fly kind of, well, these various other cons and stuff that you have as well. But I'm curious as to why, because I don't know if you did say this, as to why you decided to consider GraphQL in the first place? Like, was there something appealing about it that REST didn't offer?
Yeah, if I go back a couple slides here to this one, where I had the second example here, where we started adding in this include parameter to the URL. We were doing a lot of that. So this, like I said, this project was a document store, so it had a very large JSON document with a bunch of different fields in it. And the client didn't always want the whole document. They just needed parts of it. So we were adding a bunch of query parameters like include um, include the name and title, but not the child nodes and not whatever else. And it was getting kind of hairy and
Mm-hmm.
in that sense because we had a whole list of terms that we had to go through and document, and there were different ones for different endpoints. And I thought this GraphQL thing where you can just not only can, but you are forced to name exactly which fields you want uh, would fit a lot better. And it did fit better for that purpose, but I
Mm-hmm.
forgot I was going to go back to our independent researchers. They turned out to be the problem with this approach because they would pretty much just like to scrape the entire data set and load it into their MATLAB or whatever. And
Oh,
GraphQL made that trivially easy for them to do. So that's when we ran into the hardening problems.
so if they were going to scrape it, what was the problem associated with that for a non-technical person?
It's okay if they scrape it. They are actually supposed to email us because it's open data and we send them a tarball of it. But if they scraped it by way of iterating through our entire database, then it would have negative impacts on anyone else trying to use the website for the next couple hours.
Ah, I see. Okay, that makes sense. Huh, fascinating. Thank you for answering that question. So far, no other questions have come through.
Can I ask one?
Oh, sure, that's Mona. Is that
Yeah.
right?
Yeah, thank you.
Yeah.
Thanks, Stephen, for that really good presentation. Back on your con page,
Sure.
I didn't quite get the more latency one versus was it tied to the costliness of the productionizing
Yeah,
thing?
it's inexact terminology. I just kind of wanted it to mirror the other column, and maybe I shouldn't have done that. But it's just the thing that I was just talking about the independent researchers and the prospect of queries getting out of hand. Because serializing or combining a bunch of REST requests into one is a small win, but it's a large loss if the query ends up taking, 30 minutes to come through.
Okay, and you did mention that there are plugins now that can kind of help you limit what the user can query, right?
Right. Yeah. There's a ton of community stuff here. There's even since we discussed SQL, there's this thing called Join Monster that basically makes any SQL database work as a GraphQL API more or less automatically. So there's a lot of cool stuff happening in the space thanks to Facebook's big name and, like I said, the React tie-in.
Okay, thank you so much.
You're welcome.
That's a good question, Mona. Thank you, too. Well, thanks, Steve. We will now transition over to Marcus because we're at the half-hour point. And Marcus is now back up and running on his laptop or computer. So we'll give him a moment and I will reintroduce him. So Marcus Christie is at Indiana University where he also supports extended developer support. And his talking about Keycloak here and in our blog post is also based on his experience with working on Keycloak with a project. So I now bring you Marcus Christie.
Hi, can you hear me okay?
Yep, you're a little echoey, but audible.
Okay. And can you see my slides?
Yes, we can see that too. Yeah, thank you.
Okay, great. Yeah, my name's Marcus Christie, and I work here at Indiana University at the Science Gateways Research Center. And in the Science Gateway Community Institute, I'm involved with the Extended Developer Support Program. So I'm going to talk about the experience I've had integrating Keycloak into the Apache Airavata open source framework for handling authentication and authorization for for science gateways. So just an overview. I'll get to Keycloak eventually, I promise. I will start with kind of going over the OpenID Connect protocol and use CI Logon as the example there. And the reason for that is kind of twofold. One is that one of the main reasons that we switched from another identity and access management service to Keycloak is so that we could integrate with CI Logon. We ran into some problems with the old software we were using. And then the other reason is just to familiarize you with OpenID Connect if you've never heard of it before, because that's how you end up integrating with Keycloak for authentication. And then the second part of this talk, I'll talk about how we use Keycloak for authentication and authorization, specifically role-based authorization, and how you could do that in kind of a general way with a science gateway. And then the third thing I will talk about is specifically what we did to integrate Keycloak with Apache Airavata. So just to kind of set the stage, what's the problem that we're trying to solve? The science gateways expose a set of shared resources and APIs for manipulating or using those resources to a diverse set of users. So an example of a resource might be a compute cluster or information about a compute cluster, like how to authenticate with that cluster, how to submit jobs to that cluster. So that's obviously a resource that you would want to securely protect. And you'll have some users who are what we tend to think of as just kind of general gateway users who you want to allow them to submit jobs to that cluster. But then you'll have other users that are what we tend to call admin users who will need to be able to register new compute clusters or change the information about an existing compute cluster. So you want to allow the first group of users to do certain things with your compute cluster information and the admin users to do different things. So to be able to do that, to be able to protect those resources, you need to know who each user is. And that's the authentication problem. And then you need some way of authorizing particular users to do certain things. And that's the authorization problem. And you want to be able to do this without too much administrative overhead. And typical approaches here are to use roles or groups instead of, assigning access rights on a user-by-user basis. And then specifically for Apache Airavata and for this SciGAP project that I'm also involved in, which is the hosted version of Apache Airavata, it's multi-tenanted, so we run multiple gateways on one installation of Apache Airavata. And so we need a solution that not only solves these problems, but does so in a way that's flexible enough to service the needs of multiple gateways at the same time. So authentication, there are a lot of options here, but one that I want to talk about is CI Logon, which allows users to log in to your Science Gateway using credentials that they already have with their institution. And CI Logon provides an OpenID Connect interface to this federated authentication that they provide. OpenID Connect is built on top of OAuth 2, which is a web-based delegated authorization framework. And the way it works is basically when you have someone log into your Science Gateway through another identity provider, what's happening is the user is granting your Science Gateway the right to access some of that user's information from the identity provider, and we'll see an example of that. So this is what the CI Logon website looks like when you get redirected there to log into a Science Gateway or whatever website. You have the option of picking an identity provider. It's quite a long list of different institutions, and including, I think, Google's in there, and Gmail. I mean, not Gmail, GitHub. So I've selected Indiana University here because that's what I would use to log in. So if you were going to integrate your Science Gateway with an OpenID Connect provider like CI Logon, there are basically five parts to it. The first part is just a one-time initial setup. You register your Science Gateway with the OpenID Connect provider, and you get back a client ID and a client secret. The secret is something that you need to and then what I have listed here is steps 1, 2, 3, and 4 are what happen on every time a user logs in. So the first thing you do is you would redirect to CI Logon, and you pass your client ID when you redirect to CI Logon. Step 2, the user then picks the institution, logs in. So CI Logon has them logged in. CI Logon would then redirect back in step 3 to your gateway. And in that URL, when CI Logon redirects back to your gateway, there is an access code in the URL. And on the server side, what you do is you take that access code and exchange it for an authorization token. And then in step 4, you use that authorization token to get information about the user, like the user's first name, last name, and email address. So this is just a picture representation of what was on the previous slide. So you have from your Science Gateway, you're redirecting to CI Logon, redirects to the institutional login page. User logs in, it goes back to CI Logon, and then CI Logon redirects back to your gateway with an access code. And then server side, there are a couple web requests to get a token for that code, and then use that token to get the user information. So again, going through those steps, that one-time setup, there's a web form on CI Logon's website, and you fill out this form, and when you submit it, you get back a client ID and client secret. And I'll kind of breeze through some of these technical details of integrating with OpenID Connect, partly because most web frameworks have plugins or libraries that will take care of this for you, but I just kind of wanted to show you that if you wanted to, it's a simple enough protocol that you could implement it yourself. So when your gateway redirects to CI Logon, you construct a URL that includes your client ID and the URL that you want CI Logon to redirect back to. Now I skipped step 2 because that's just the user logging in. The step 3, CI Logon is going to redirect back to your gateway, and then in this first box there in pink is the code that it's handing back to your Science Gateway. And then in that second box, in the box in the middle here, is a post request where we use our client ID and secret and the code that we got back from CI Logon to make a request to exchange that code for an access token. So those bottom boxes, the response back from that request. So now we've got the access token. And in step 4, again, we can make another request to the user info endpoint, and we're authorizing using the access token. And then in the box on the bottom, we're getting back a JSON response with all sorts of user information. And at that point, we've got the user logged in. So for a OpenID Connect provider like CI Logon, there are a couple different ways you could integrate with it. You could integrate with it directly, which is kind of like the approach that I talked through in the previous slide. The other way you could integrate with an identity provider like CI Logon is through an identity and access management server like Keycloak. That's what this indirect approach is over here on the right. So the way that works is, instead of your gateway redirecting to CI Logon, your gateway redirects to the Keycloak server, and the Keycloak server redirects to CI Logon and starts the OpenID Connect process. So once CI Logon redirects back to Keycloak, Keycloak will call the CI Logon's user info endpoint and get information about that user. And then Keycloak will create a user record in its database, and it will finish the, actually there's basically 2 OpenID Connect requests going on here. Your gateway makes an OpenID Connect redirect to Keycloak. Keycloak makes an OpenID Connect redirect to CI Logon. Then it comes back to Keycloak, and Keycloak creates a user record if one doesn't already exist. And then Keycloak redirects back to your gateway with an authorization code, and use that authorization code to get an access token and the user information from Keycloak. So, so then why would you use an identity and access management server like Keycloak? Well, for us, especially in our multi-tenanted environment that we have with Apache Airavata, it gives us a lot of different authentication options. So not every gateway will want to use the same authentication options. Some gateways want to use just CI Logon. Some gateways want to only use, allowing users to create an account on the Science Gateway, create a unique username and password. And there are other authentication options that Keycloak supports, like if you have an LDAP server that you want to authenticate against, you can do that. The other nice thing about using an IAM server is you can do the software integration with whatever your gateway client is, like if it's a web portal, you can do that once. And then changing your authentication options is just a matter of configuring that IAM server for that gateway. And then the third reason to use an IAM server is for its authorization services. So if you integrated with an OpenID Connect provider like CI Logon directly, that solves the authentication problem. That lets you know who these users are, but it doesn't really help you with authorizing them to do various things. Now you could always do a lot of web frameworks have their own kind of built-in authorization abstractions that you could utilize. But one advantage of using an IAM server is that these authorization services are provided as a service within your middleware. So you can authorize users not only in your web application, but you can authorize users who are calling your API directly. So we ended up, because of all those reasons, we needed an IAM server, and we ended up looking at a couple different ones and selecting Keycloak. Keycloak's an open source identity and access management server that's sponsored by Red Hat and has a reasonably active community of contributors. It supports identity brokering, like the example with going to CI Logon to log in a user, and you can plug in different authentication mechanisms. It has several different ways that you can handle authorization. So it supports attribute-based access control, role-based access control, group-based access control. So you can pick the one that makes sense for your gateway. It's multi-tenanted, so a single Keycloak server could have, they call them realms. Each tenant is a realm within Keycloak, and so each realm has its own identity providers configured, its own user store, its own authorization mechanisms, etc. And Keycloak also has a complete, well-documented REST API, which is important for us for automating things like creating a new tenant and creating and updating users in Keycloak. So how would you, so this is a screenshot of Keycloak, and in this screenshot, we're going to add an identity provider. So here I'm going to configure Keycloak for using a CI Logon as an identity provider. And on the next screen, basically I have a form to fill out. There are a few different URLs, the authorize token URL, the user info URL, and then here you see the client ID and the client secret that I got back from CI Logon when I registered with it. And you know, that's about it for, because again, it's OpenID Connect is a standard protocol, so this stuff is pretty standard. So how would you integrate something like Keycloak into your gateway? So again, Keycloak's multi-tenanted. For a gateway, you would create a realm for that gateway, and then you could configure that realm with your authentication options that you want, like CI Logon. And then you need to integrate your web portal with Keycloak to do OpenID Connect for authentication. So what you do is you redirect your users from your web portal to Keycloak, and they sign in there, and then Keycloak redirects back to the your Science Gateway. And then to handle sort of like administrative tasks like creating new users or authorization tasks like managing what roles a user has, you can use the REST API to do all that. Okay, so that's kind of generally how you would integrate Keycloak with the Science Gateway. With Airavata, what we did is, with Airavata, we have an API that we expose for querying for information about scientific applications, compute clusters that you can run those applications on, and launching them on those compute clusters, and methods for API methods for manipulating those resources, which we generally restrict to admin users. And so the flow that we have in Airavata is that from the gateway, so step one is we'll log the user in and we'll get an OAuth access token. And then once we get the user logged in and we have that access token, we'll pass that access token in every request to the Airavata API. So that's step two. Then the API server in Airavata we'll take that access token and validate it so it calls back to the authorization server in that case. So let me back up just a little bit. So the authorization server here is Keycloak. So the API server will, in step 3, make a call to Keycloak to validate that token. And assuming it's valid, it will then make a call to Keycloak's REST API to get the roles that user. And then it'll look and say, okay, this user has these roles, and this user is trying to call this method. Does the user have a role that can access this API method? And if it does, if the user has a role that can access that API method, then the API server allows the request to go through. So we created, in Apache Airavata, we created a service that integrates with Keycloak's REST API for managing tenants and users. So we have a tenant management part of the profile service. So we can create a tenant, and this calls the Keycloak REST API to create a realm, create a set of roles within that realm, and create an admin user in the realm, and set up a default client for the web application to use to authenticate with Keycloak. And then for user management, we have things like creating users, enabling users when they. So enabling user is not something we would use in the CI logon case, but we do have gateways that need to allow users to create username and passwords on the gateway. And when they do that, we verify their email address. When their email address gets verified, we call this enable user method, which will then call the Keycloak REST API to update the. And so there are also Keycloak REST APIs to update the roles that a user has. So then I've got some screenshots just to show you what this looks like from the user point of view. So this is a user logging into one of the gateways we host called Cgrid. So this is a gateway that supports a couple of different authentication options. You can have an account on Cgrid, or you can sign in with CI Logon. So I'm going to pick CI Logon. And when I go to CI Logon, I'm going to select Indiana University. And this takes me to the IU authentication page. I log in there. And we have this two-step two-factor authentication log on here at IU. So that's kind of nice. This is IU's authentication. Like most institutions, they have a very secure authentication mechanism that you just can tap into using a service like CI Logon. Okay, so then this redirects back to the Cgrid Science Gateway, and then logged in. Now, what happens, the way the role-based authentication works is when a user logs in for the very first time, they can't really do anything yet because they don't have a role that allows them to do anything. What we do is we assign users to what we call the user pending role. A user pending is just kind of a bucket to put new users into, so admins can go in to the gateway and see all the users who have the user pending role, and then assign those users a role depending upon who the user is. And this shows you the admin view. So in this view, you have an admin who is looking at my user record, and so the admin has added the gateway user role to my account and removed the user pending role. So now I can put jobs gateway. And then the role gets used in the API server, like I mentioned in a previous slide. It also gets used in the portal to kind of hide and show functionality. based upon the user's role. So we don't show the user, if the user isn't an admin, we don't show them admin views in the portal because they wouldn't be able to use it. And I think that's it. So if there are any questions, and if you think of some question later and want to email me, there's my email address.
Thanks, Marcus. Perfect timing. Mona sent in a question, which was, can a user authentication and authorization go between Keycloak realms? I hope that makes sense to you. I know you were talking about there being different realms within one of your setups there.
Yeah, I don't think so. I think the realms are meant to keep these set of users and things separate from each other. But I know that's an interesting question. Maybe there is a way, but I don't think it would allow that.
Yeah, so there haven't been any other questions coming in just yet. Mona says thanks. So I think that is good there. I'm going to share my screen so I can tell folks about the upcoming webinars while people give some more thought to if they have any other questions, because we have a minute or two more that we could ask. So, but thank you in the meantime for providing that. That was helpful and interesting to know. And I just want to remind those who are on the call that not only will the slides be available, but this discussion is also provided as a tech blog post on our website, so you can get detail and recap there in written form. So put your thinking caps on and see if you have any questions for Marcus. But while you're thinking about that, I just want to let you know I have put a link to our evaluation on our through chat, but you can also just type in this URL to provide us with your feedback. Also, we have 2 upcoming webinars in the next month. We have our regular one in July, but before then, at the end of June, we have a special edition webinar, which is takeaways from the Science Gateways Bootcamp. It is 2 days before the extended application deadline for the August bootcamp that we're going to be offering. So it's a great way if you're wondering whether bootcamp is a good fit for you, or even if you just want to learn some cool things about what's happening in bootcamp, to get a flavor for what kinds of things people learned and have been applying from attending the bootcamp. That's on June 27th, and then at our regular second week of the month webinar on July 11th, we'll be having a webinar about bridges, which is a resource provided from the Pittsburgh Supercomputing Center, and Nick Nystrom will be presenting that. And then I'll just also mention one last pitch for those who might know someone who would be interested in participating in our hackathon. The information about that is linked from our student-focused section of our website. So I see it's the top of the hour, and are there any other questions that are coming in? I don't see any. So with that, I'll let everyone go, but thank you, Marcus and Steve,